This is the equation that we're going to be working with today. This is an absolute value equation. There's a couple of things that we need to go over before we can actually solve this inequality like the question asks us. The first is that we're looking for all points whose coordinate x is a distance greater than or equal to 3 units from the origin. We get this greater than or equal to 3 units from the origin from this area of the inequality. So I'm actually going to show you this on a number line because it's the easiest way to see it. So this is our origin, 0. There are two ways to satisfy the distance of 3 units from the origin. We can either go to the right 3 units or we can go to the left 3 units. If we go to the right 3 units, we are at a positive 3. And if we go to the left 3 units, we are at a negative 3. But as you can see, both of these are equal to 3 units. We can think of any absolute value equation as the distance from 0. And this area of the inequality right here provides us with that distance from 0. So in our case, the distance from 0 is greater than or equal to 3. So this gives us two very distinct regions. We can either go to the right or we can go to the left. And there's one statement that allows us to help solve this inequality that we need to go over before we can actually proceed. And that is the absolute value of u just being a general for any absolute value, when it's greater than or equal to a, is equivalent to u less than or equal to the opposite of a, or u being greater than or equal to a. This works with any greater than symbol, whether it be greater than or greater than or equal to. All you would do is simply this, instead of being a less than or equal to, this would just be a less than sign, and this would just be a greater than sign. So the u, the absolute value of u right here, is equivalent to our absolute value, being 7 minus 5x. And this general a, in our case, is equal to 3. We use this or right here because there are two distinct regions, to the left and to the right. An or is used whenever there's a greater than sign, which is here, or a greater than or equal to sign. And there's one very clever way to remember this, and that's simply by just looking at the word greater. So greater is equal to or, and you can remember this by simply looking at, here's or, right here. So whenever you have a greater sign, or a greater than or equal to, just remember that you use your or statements. So let's return to our inequality problem. The absolute value of 7 minus 5x is greater than or equal to 3. Your first step would be to get this absolute value alone, but in our case that's already done. We have our absolute value on one side and it's separate from all of the other mumbo jumbo on the right hand side. So remember that our distance from 0 is 3, which provides us with those two distinct regions. So our next step is that we're going to set up the problem based on our previous statement that we made. So that statement, again, just to remind you, is the absolute value of u when it's greater than or equal to a is equal to u less than or equal to the opposite of a, or, there's our or statement, u being greater than or equal to a. So based on this statement, we're going to set up ours. So 7 minus 5x is less than or equal to the opposite of a. So our opposite of a would be the opposite of 3, which is negative 3. Or, here's our or statement, 7 minus 5x is greater than or equal to a, which is 3. So here is our problem right here. Our goal now is to get x by itself, so that way we can have our solution. So the first step is that we're going to need to subtract 7 from both sides in order to get rid of that 7 on the left side. One thing to remember when you're doing this is whatever you do to one side of the equation, you have to do to the other. So if I'm going to subtract 7 here to get these to cancel out, I also have to subtract 7 from the right side of the equation. And this here would leave me with negative 5x is less than or equal to, and a negative 7 plus a negative 3 is equal to a negative 10. Now let's also do that same thing over here. So we're going to subtract 7 to get them to cancel out, and we're also going to subtract 7 to the other side because that's what we did to the left. So on this side we're left with a negative 5x is greater than or equal, and a negative 7 plus a 3 is a negative 4. Remember to write that or statement in there. So now, to get x alone, we will now have to divide both sides by a negative 5. And there's two things that you need to remember when you're doing this. First is, again, whatever you do to the left side of the equation, make sure you do it to the right side of the equation and vice versa. And the other thing is that when you divide by a negative number with inequalities, the sign flips. So in other words, when dividing by a negative number, it reverses the sense of the inequality symbols. So I'll show you that right here. So in order to get x alone, we're going to divide by a negative 5. These are going to cancel. So we're left with x over here. Again, we're going to flip that inequality sign. So instead of being a less than or equal to, it's going to be greater than or equal to. Divide by a negative 5 because we did it on the left, so we have to do it on the right. So we're going to get negative 10 over negative 5. There's our or statement. And on this side, we're also going to divide by a negative 5. Those 5's cancel. We're left with x. Now our sign is a greater than or equal to, so we're going to flip it. It's now going to be a less than or equal. We're going to, again, divide by negative 5, so we're left with negative 4 over negative 5. Our next step in this problem is to simplify all of our answers. So what we're going to do, this 5 divides into 10 very nicely. And remember that when you divide a negative by a negative, the result is a positive. So we're going to get x is greater than or equal to a positive 2, or x is less than or equal to 4/5 is already simplified. The only thing that we can do is remember that when you divide by a negative number by another negative number, it results in a positive. So you'll get a positive 4/5. So right here is our solution. But our original problem asks us to state our answers in set notation using a number line and also an interval notation. This answer is in none of those forms. So what I'm going to do is we're going to rewrite our solution up here. So x is greater than or equal to a positive 2, or x is less than or equal to a positive 4/5. So the first one and solution that we're going to write it in is set notation. And this is basically just defining x. And set notation is written like this. And then you simply just write your answer that you got to the last problem. So it would be x is greater than or equal to 2, or x is less than or equal to 4/5. And again, this is simply just to define x. This is your set notation answer. The second way it wants us to do it is using a number line. So first we're going to start off with our number line. The first thing we're going to label is 0, so we can find our two solutions. So we'll start with 2 and label 2. And remember that 4/5 is slightly less than 1, so we're going to go a little bit before half of 2. So here's our half of 2, so we'll go about here, and that is 4/5. Now let's start off with this first section of our solution. Our x is greater than or equal to a 2. So if x is greater than 2, our solution is going to be going to the right because we want all of the solutions that are greater than 2. So we're going to shade to the right of 2. And another thing to remember is that with these, the way to denote whether you're going to include 2 or not 2 is whether or not you use brackets or parentheses. So if you have a less than or a greater than sign, you're going to use parentheses on the number line to indicate that it looks like these two inequality symbols. If you have a less than or equal to or a greater than or equal to, you're going to use brackets. And this states that these answers are included within your solution. So in our case, we have a greater than or equal to sign, so we're going to use a bracket. You simply just bracket it off. So next we're going to look at the second solution to us, and that's x is less than or equal to 4/5. So if we're less than or equal to 4/5, we're going to be going to the left of 4/5. We want all of the answers that are less than 4/5. So we're going to shade the left side of our number line. And again, we have a less than or equal to, and when we have a less than or equal to, we use a bracket to show that we're including that answer on our number line. So this right here, I'll get rid of this, is our number line solution. And lastly, they want us to write it in interval notation. And this is done easiest by looking at your number line and also focusing on the endpoints both on the left-hand side and the right-hand side. So you want to first look at your number line. Your number line will start off on the left-hand side of our number line. Our left furthest endpoint, just notice that this just keeps going off. This just keeps going off into infinity. So we're going to go negative infinity. We're going to use a comma to separate our left and right endpoints. So there's our comma. And we just keep going, and keep going, but we stop at 4/5. So we're going to write 4/5. And whenever you have an infinity sign, you're always going to use parentheses. So there is our parentheses. So whether you have a negative infinity or a positive infinity, you use a parenthesis. Now after the 4/5, remember we want to include that answer, so we're going to use a bracket. We use this symbol as a U to show that there's a union between the left side of the answer and a right side of the answer. So this just joins the two solutions that we have. So our left endpoint on this right side of the graph is a 2. And our endpoint for this right side, it just keeps going again, so it's infinity. So we're going to use a comma to separate our left and right endpoint, and we're going to do an infinity. Again, we have an infinity, so we're going to use a parenthesis. And the 2, we use a bracket because we want to include the answer. So this right here is our interval notation set. And as you can see, here's our 3 answers that you can write when you solve an inequality. And that's it.